New. So, okay. So today is the first class, the season for first day of the season for data engineers. So if we are just, quite passionate to join as a data engineer in a company, so this is a crash course that should be helping us over there for the interview as well as some basic concept. What kind of works we are actually doing over there, and what is the significance of the data engineers? Of course, this is the main stuffs. So actually, data engineers is the first thing, but maybe if we are working over there in a big company, we should be receiving a small part over there. Maybe we can work only top of an ETL part. Maybe someone should be working on top of visualization part for data analytics. Maybe some people is working on top of data scientist role. So, on top of data, they are working to have the growth of the business of the particular company. So this is, that is why data engineering part is very much important nowadays in each and every enterprise solution. So they're recruiting on top of that one. Okay, hopefully everyone can see my screen, correct?
Yes.
Okay, yeah, I received some message over there. Okay, thanks, Varun. So, first of all, today is the basic introduction on top of data. What is data? How the representation of data we can able to see or we can prepare the data. Okay, so those kind of stuffs you can quickly learn for today. From the next day onwards, we can quickly catch up on top of data, what operation we can do. For structural data, we can go ahead with SQL language, SQL, structured query language. So that thing should be started maybe from the day after tomorrow. Tomorrow we'll be learning something more about tabular form of the data, the normalization form, and some databases. What is database and how to install the databases? Those kind of stuffs we can learn tomorrow. And the day after tomorrow, we can totally, it will be programming thing on top of SQL language, structured query language. By this language, we can go ahead with, programming on top of tables. We can, just like do some kind of data analytics part. We can aggregate the data on top of some columns. We can create the tables. We can update the tables. We can update the data. We can aggregate the thing. Lots of things we can do. That thing can be covered. So maybe the SQL thing we can cover up for 1 week more. Then we can go ahead with Python stuffs, the basics of the Python, then how Python can be used as a data engineering purpose. So for Python, that should be 1 week more after the SQL is covered. After that, we can go ahead with some topic on top of Hadoop, some topics on top of cloud computing, especially AWS, and then we can cover some topic on Git. Git is a code based repository. So whatever code we are writing over here, that in our enterprise version, we need to store the code somewhere else. That is the repository, GitHub repository. Okay. So some basic concept on top of Git as well. So those are the topic which should be covered for this entire season. Maybe 1 month it should be required for the covering of the particular steps, so we can gradually learn more of the things on top of that. But if there is any stuck point, maybe some days we can go ahead with some basic task to be completed at our home and to come back again with the next day if there is any doubt or just like this. Even we can check what are the issues and all while doing or solving those problems. Maybe in a week, once or twice, we can go ahead with that stuff. Okay. But I'll be requesting you for be interactive. If there is any doubt, please ask me. I'll be trying to solve this thing in the session itself. If not possible, I'll be taking up your questions. Maybe in the very next day morning, I'll be showing you. Whatever. I'll be trying to help you the solution. What should be the solution and all. Okay. Okay. Then. Hope we have enough. Yeah. So we can start this thing. So what is data? Data is the collection of information, obviously, we know. And I mean, what kind of data we are, I mean, we'll be able to store over here for data engineering purpose. That should be, I mean, some quantity, some quality, fact, fact dimension. Those are the things we'll be covering while we'll be learning business intelligence part, maybe 2 weeks later. But just a basic introduction, those are called data actually. So, I mean, data, we can collect data in anywhere actually, just like sales transaction in any shopping mall and this kind of stuffs. We are collecting data daily basis for each of the transactions. For banking transaction, we are collecting all the information for banking, for a particular person's credit, debit, everything, daily basis transaction. Just like for a insurance company, their transaction, medical company, they are having transactions. Uh, just leave it. I mean, if we just have some sensor in some digital hardware, okay, so that sensor is collecting data. Maybe a sensor, there is temperature sensor. Okay. So it is also collecting some data. Just like in aeroplane, there is altitude sensor as well. And it's having the data. I mean, it's updating the data per second or per microsecond. It's collecting the altitude or maybe the latitude, longitude of that aeroplane each and every time, and it's storing in the information in somewhere, and that input or that data is being used again, and that should be fed to the pilot so that they can maintain proper, I mean, alignment with the plane and all. Okay, so this kind of data we are extracting the data for various purpose, but the same data is being used again for the same company for increasing maybe their business growth, or maybe just like for aeroplane to maintain proper balance of the aeroplane, just like this thing. So data is itself, we are generating the data for ourselves only, for uh, for the, I mean, self growth, we can say, for a particular business. Okay. So moving to the next slide, what is there? Let's check. Okay. So purpose of data engineer. So what we are doing actually, suppose let me, I mean, we are a data engineer. Suppose we joined a company which is having, I mean, a lot of business outlet for a particular shopping mall. Okay. So over there, we are with the data engineers, we are taking data from the source system. Source system means daily basis transaction. They are pushing it to some tables or some source system. Maybe it's a flat file or some other source system. Maybe it SAP, HANA. Maybe it's something, some new databases, just like Oracle, Microsoft SQL Server. They're storing somewhere the daily basis transaction. Okay. And the same transaction is provided to the data engineer. What data engineers actually do, they build, they just actually taking those data and they're proceeding with the meaningful data on top of those source data. Okay. So after processing of this particular source data to meaningful data, then the data, I mean, the particular maybe business intelligence team, the data scientist team, they're preparing out there, they can take the proper decision on top of the hidden trends or hidden pattern. Maybe they are having some loss, a hidden loss is there for a particular product, but we cannot able to understand particular which product is having the loss. So that kind of hidden pattern that can be easily recognized by that particular organized data, what data engineer can able to build. Okay, so that's why the purpose of the data engineer is to process the source data to meaningful data or the organized data in such a way that the particular decision owner from the business side, they can take the decision for their business growth. That is the thing. Any questions till now? I got some noise or just like this. Any questions till now? Okay, hope no. So that is the purpose of the data engineer. Suppose, let me give an example. So uh, maybe we have a big company over there who is having outlets of product, maybe shopping mall or just like this. So maybe in uh, we have 50 states. So in 50 states, each of the states they are having 10 to 15 outlets. Okay, for that particular big company. So they have produced some particular product, but for some outlets that particular product is having maximum sales, but for the some outlets it's having minimum sales. People's around that particular shopping mall, it's not purchasing that particular product. Okay, so by checking on top of data, we can easily understand that particular pattern. So after that, decision maker will take the decision that they will have the less production or less distribution of that particular product where the sale is less for that product. They will not distribute the product to that outlet anymore, and they will be pushing the same product into other outlet in other region where it is having more demand. So this kind of quick concept, I mean, that should be increasing the revenue of the company, and it's very smart type as well. So we can also give the feedback to the factory as well that we do not need this product anymore, because there should be some manufacturing cost on top of that product, so that can be removed. As well as we can, if any product is having high demand, then that can be also produced in large scale. So this kind of concept we can do, but that particular hidden pattern of which is, I mean, doing more, I mean, profitable thing, which is doing less profitable thing, that can be quickly catchable by the data over there. Okay, by the organized data. If we have ready-made organized data, on top of that, if the visualization team just create the graphs and charts, by checking those graphs and charts, it's very much easy for the decision owner to make the decision. Okay, so that is the whole purpose of data engineer. So that's why in each of the enterprise solution, they are, I mean, very much keen to recruit data engineers nowadays. Moving to the next slide. So just, I mean, I just give those examples already. So what kind of data engineers they are recruiting, just like on top of banking, commercial, insurance sector, medical sector. Medical sector means if we have pharmaceutical company, they have lots of medicines, just like for Johnson and Johnson. They are having pharmaceutical product as well as some commercial product, as well as some medical devices. I mean, what is been used in hospitals for operation purpose, OT and all. So lots of devices they are doing. I mean, they're creating their databases and storing those information on top of those kind of stuffs. So those are the type of data, and those are the type of different sector that the data is being stored. Okay. Now, this is the topic on how the data is getting stored in databases. DB means databases. Okay. So if we segregate the database, there are two kind of database or data representation. One, you can see it's a tabular format. We are having two columns. One is called name, another one is called email. Okay. So in name, we have inserted two particular rows, the first row and second row, and the same data can be represented in this format. Okay. We can say this thing is a JSON, or we can use Python dictionary as well in this format. If you're already out of YML, XML, that is also, this is the format of representing of the same data. We are not using columnar format over here. We are splitting this thing and putting inside line. Okay. So the first one is called the relational database. That is following the tabular structure. And this is called, this kind of data representation, it's called non-relational databases. And it should be some key value pair. Key should be, I mean, the same thing is over here is a column name. Okay. And value is the data. Okay. This is the data. Email, this one. So the key value organization is there in non-relational database. So I think you are quite aware of NoSQL part as well nowadays. So those are storing information in this way. SQL is storing information in tabular format. It's a representation of relational database, and NoSQL is the representation of non-relational database in this way. Okay, but the data is same. The data representation is same. You can check this thing over here. Okay, going to the next slide. So I'm coming to the relational data. Okay, so relational database, obviously, what are the properties for the relational database? We quickly catch up the thing. So obviously, we can store the data in tabular format. Okay. Okay, and the table, I mean, if we have multiple tables, we can have relations between the table. We can set up the relations between the table. That thing I'll be coming later with a quick example. So how to set up the relation? There is the statement over here. For particular tables, we should be having primary key. For another table, we should be having some foreign key. So there is some join operation between two tables where we can set up those relation between two or multiple tables. Okay. So uh, that is the, I mean, that is why as we are able to set the relation between tables, that is why it's called relational data. So primary key, foreign key concept is very important. Maybe, I mean, in details, we'll be covering the same steps in tomorrow's session. Just I'm giving a quick heads up to you so that you should be having clearer picture. Okay, so this slide we can have some idea. So we can able to set up relation between multiple tables. There are four tables. Over here, the first table is for customer table, the second table is order table, address table, and this table is product table. The first table we are having customer ID, customer date of birth, and particular order ID that particular customer has been bought over here, and address ID. Over there, you can follow that customer ID is the primary key because this is unique in nature for the customer table. Okay. And in order table, we are having order ID is the primary key for order table, but the same column is the foreign key for customer table. So by order, as order ID is a common key, we can join between these two tables based on order ID. Okay. So we can fetch all the information of this table into this table by this common column. Okay. The same thing happens over here as well for address table with the customer table. We have address ID over here, address ID over here as well. So if we just want to get for a particular customers, what is the address, line one address, what is the pin code? We can quickly join between these two table, customer and address table with the help of address ID, and we can fetch information of the pin code of that particular customer. Okay. The same thing for product as well. Product is getting joined with order table on top of product ID. But if we want to check what particular product or what particular ratings the particular customer has been given to that product, so we can directly join between these three tables. First join between two tables, then these two days, then we can fetch all the information for this customer. So that is why it's relational database, RDBMS database. We can set up relation between two or multiple tables. And why we are setting up relation? To fetch the information from one table to another. Okay. In detailing part, while doing the SQL operation in join, I mean, we can join multiple tables. We have that particular classes, maybe later chapters. So we can talk in details on top of that in later section. Okay. So let me move to the next slide. If there is any doubt, please ask me. Till now, we just covered what is relational databases and just a quick thing. So maybe from tomorrow's classes, we will be focusing on relational database because I mean, much more data analytics part, it's been covered only on relational database by using the SQL, structured query language. So basically in NoSQL, we'll be just quickly touching on the high level for today or maybe the day after. I mean in tomorrow as well, the NoSQL part. But I mean, for data analytics purpose, the main focus should be on top of relational database on that kind of tabular structured data. So we'll be carrying forward with relational database. Uh, okay, from next day session. Okay, moving to the next slide. Give me 1 second, please. Okay. So that is the thing. What is structured query language? So this kind of, joining part at that I was referring that while checking the tabular type of data, or on top of that tabular data, if we are going ahead with some of the operation, some aggregation, some Windows function, there are lots of function as well over there. So we should be using structured query language. In short, that is called SQL or SQL, anything. So the particular language should be looking like in this way. Just like select, those are the column name, from is the keyword, then the table name. Table is that particular table. And this is some filter over there. Those kind of language we should be using maybe after 1 or 2 days, in particular query editor or just like this. Okay. So this is called structured query language, but don't worry about, if you are new resource or you are just, you will be learning the SQL thing for the first time, then we can quickly learn that particular stuffs in later section. Just this is a brief thing over there. Now it's time for non-relational databases. That key value pair we just have seen over there. So those are the representation of non-relational databases. So we cannot set up relation between two particular tables because we are not following the tabular structure there. Instead of doing that, if we just want to append, there are some also advantages over there in non-relational database. Suppose we want to add an extra column, then we need to update the table structure in the relational databases. But in non-relational databases, we do not have to add this kind of tabular structure or anything. We can directly add this key value pair for a particular line. So this is very much, it's very first. While retrieving the data from that non-relational database, it's very fast. Just like while designing a chatbot, if a particular resource type anything, and to get the same answer from the database itself, they're using the storage method as a non-relational database. Or by, this is, particular, there are lots of applications. Some applications they are using non-relational databases. Some application they're using as a relational database. So based on how fast it is in nature, or based on what particular uh, analytics we will be doing in going forward session. So if we are doing lots of analysis part, then we will be choosing SQL part, that is relational database. But if we just want to choose, a very first retrieving data without any analytics part, then we should be choosing non-relational databases. We should not be having any tables, any fields, any columns, just like structured data concept. We should be only having key value pair and store the same thing in this manner. In NoSQL database, we can go ahead with hierarchical manner as well, which is not possible in tabular structure. Why it's hierarchy level? Let me show you. Yes, this is an example for non-SQL, and this is a JSON as well. So you can see, just like first name, last name is active, age. Over there, address is a key. Inside address, again we are declaring another key value. So it's a hierarchical level key value pair. Okay, which is not possible at the SQL side. To quickly show up you the hierarchical structure inside the same data, it's not feasible over there, but it's feasible over here quickly. Inside address, we are generating another set of key value pair, street address, city, state, postal code. Okay. So this kind of stuffs, there are some advantages over here, but some advantages over there as well. So we'll be choosing, or our data architect, whoever is owning that particular project, they should be choosing what kind of databases should be used in our example, or in our particular project, particular application. So that should be understandable, I believe. Any concern till now from anyone? Okay, hope no. But please feel free to ask if there is anything. Then we can quickly try to solve our doubts inside the class itself. Okay. Okay. So some more insights on top of relational databases over here. So just like what data engineers actually do, data engineers build those kind of meaningful data from the raw layer data from the transaction level. So I can show you in transaction, we are getting each day's transaction. So we can aggregate the thing based on year, just like this kind of year and revenue kind of tables we can quickly generate. Then inside the data team, there are the visualization team as well. They have worked on top of building the graphs, charts, and all. So there are various tools to build this kind of stuffs. The business tools. We can create the same thing in Excel as well, but in Excel, it's not. It's not compatible to handle the millions of records over there. For that things, we have separate business tools, just like Tableau, ClickSense, Cognos. So we are using millions of records and creating this kind of charts and graphs. Now, when business user can check this kind of graphs, they can easily determine that how our growth is, what is the slope of that particular line. On top of that slope, they can easily take the decision of what is the growth. And maybe if they want to uh, make the growth in large scale again, then they will take that necessary decision, or they can check their historical losses as well. What happens at that time? They can try to resolve this kind of thing earlier. So that particular hidden trend as well as they can, they can take decision based on their history as well, and they can forecast their business. Okay, so this kind of checking by the graphs, they can take easy decisions from their side. There is not only, simple line graphs as well. There are lots of interesting graphs and charts nowadays. They are having just like histograms, pie charts. So those are very much helpful. Box plot is there, uh, scatter plot. So each of the plot is being used for each of the purpose. So data analytics team, visualization teams, they are expert on top of choosing which graph should we take for representation of the data. So maybe sometimes data scientist team also help them to choose that particular thing. Okay. So moving to the next slide. Okay, I have an Excel over here. Let me show you. Yeah, day one class. So the same charts and graphs. I'll be showing you in that example. So over there, I have a particular Excel. What is the sheet one? Same thing. So over here, we have a table where we having product. Those are the column, product column, price column, discount on top of those price, and this is the final price. Okay, just I want to show you a basic example of representation of the same data with two particular graphs. Okay, let me show you. Uh, uh, okay, insert. I can insert the everything in a 2D column. Okay, let me take this graph in a template. Okay, sorry. Rosai. Okay, so I just converted the thing into this bar chart. Okay, so you can see we have just like this is representing the price of cap. This is the discount of the cap. This is the final price of the cap. Okay, we are splitting the entire setup thing first of all on top of product. Okay, then we should have to calculate the final price over here. The same type of data can be calculated. The same, I will be creating the same bar plot again, but I'll be splitting this kind of stuffs in a separate manner. Let me show you. Okay. So let me pick this thing up again so that we can understand the difference. And what is more meaningful. So this is the representation of data. Maybe we can take the correct decision, or maybe we have to get help from our business person. Okay, let me maximize the screen. So what we have done, the data is the same thing, the raw data. We are having three products. So over here, this set of data is top of product. Okay. Uh, Sorry, not on top of product. The top of product, I mean, on top of product, we are splitting the inner thing. Just like blue is for cap, board is for this one, and pen drive is this color. So each of the thing, the first splitted thing is price, second thing is for discount, the third thing is for final price. We have the same raw data, but we just, replace the thing over there. So we have taken now the things, the first thing as a cap, the second, this thing as a product, the second product that is called board, that is for pen drive. And instead of splitting the part or dimensions or column names in this way, we have split it in this way. The first is for price, second is for discount, and third one is final price. So I think this is more meaningful. This is for a particular product, this is another product, this is another product, and we can easily check. This is the graph for price, this is cap, and this is the final price. So we can represent the same data, but which is more acceptable from the business user. We need to take that decision as well if we are working as a visualization engineer on top of data. So which dimension I'll be taking in this, and which one I'll be putting over here. That is also, that decision we need to take. If our business user tell in proper way, we need to maintain the same thing. Okay. So I just give you a basic example. That is understandable what I try to learn. Try to speak over here. If not, please tell me. Okay, hopefully yes. So we just splitted
Yes,
column.
good, sir.
Okay, okay. Just I'm quickly repeating. I splitted or I replaced whatever column I have represented over here and here. I just replace the same thing from here to here. But which is more meaningful, you can quickly understand. If the particular user want to see the final price in a single chart, they are not bothered about this thing. They'll be concentrating on the final price. Then that is fine for them. They only check this thing, these three. Okay. But I think they'll be checking what are the market price, what are the discounts, and everything for every product. Then I think this is more meaningful. But it's same bar graph, same data I'm representing over here. But we need to understand what the requirement is, and we need to design in this manner only. Okay. So just moving to the next slide. Yeah, that I was telling that there are various visualization tool that whatever I have prepared in Excel, the same thing. In organization, we do not have to prepare the thing in Excel, or we do not have to store the data in databases. We have to store in databases, not in Excel. If there are few data, maybe some thousands of records, or maybe hundreds of records, then we can store in Excel, or maybe in CSV, comma separated file over here. Okay. So those are called flat file as well. So we can store those kind of data in Excel if we have very less numbers of data. That is fine. We can also work this thing as our source system. But specifically, we are using some databases for storing those data, as we are having daily basis, lakhs of transaction, millions of transaction. Okay. So maybe if we are just storing the historical information as well for daily basis, then the record should be reaching in billion. Okay, so Excel will not handle this kind of data, or Excel will not prepare those kind of visualization technique for those large data. So that's why we are using this visualization tool in our enterprise solution. So now there are Tableau, Click, Power BI. Power BI is a Microsoft product. I think you are quite aware. Or someone of you maybe must have some knowledge on top of Power BI as well. Cognos. So those are called visualization tool. Okay. Where we are preparing those charts, graphs, and all. Okay. So till now we have learned this thing. And just give me some quick more insights on top of database because this is the last slide. So tomorrow, I mean, just like the same data, what we are storing over here in Excel, just like this data. If we, I mean, in real enterprise solution, we should be having various kind of databases to store the data, just like MySQL databases, Oracle database, SY base. This is from SAP side. Uh, there is, I mean, DB2 from IBM. I mean, each of the enterprise, they have their own thing, or they are buying the thing, or they are renting the thing from particular organization or particular database. I mean, options. Just like there are Snowflake, there are Teradata, Microsoft SQL Server, Oracle. I already spoke it about. So those are the various databases. We need to choose what database we need to take while configuring our project. I mean, not actually from our side. If we are the basic learner over here, we do not have to choose actually. The architect, the data architect, those are very senior level position. They'll be choosing what kind of databases should be used in the project, what kind of tools we will be using inside the project. They will be choosing for us, and we'll be going and on developing on top of that tools. I mean, on top of that databases only. And most of the databases, and we should be having the same kind of SQL query language, but there are some or a few changes in the syntactical. Just like for few inbuilt function, we have separate syntax for each of the databases. We will be choosing one particular databases in tomorrow's session. It's called MySQL database because it's an open source database with having free cost. You can download that one, and we can install the same thing at our own machine. Okay. And while installing, after installing that, I mean that thing, we can learn the thing at our side by creating the tables over there, and by creating the tables columns, by updating the tables, by analytics on, I mean, doing some analytics on top of the tables and all. We'll be performing everything on MySQL. This is a database. So I'll be giving you a particular link, maybe a YouTube link, to how to install the MySQL database at your own system. So I'll be requesting you to install the same thing at your side. I'll be discussing again the same topic tomorrow again. Just a quick recap. And I mean, whatever we have learned for today, just have a quick recap. Just have the knowledge what is the difference between NoSQL and SQL, those kind of stuffs at your side. Don't think it's a homework, just for learning that same thing at you. If you are new I mean, if you are new to learn this thing, or if you are just going to have an interview between, I mean, SQL and NoSQL, just a basic, then, I mean, they can quickly ask you what are the advantages, what is more cost effective. So this kind of stuff we can quickly learn after checking the same thing in web as well in detailing manner, as we are learning the thing over here in a crash course. Maybe it's a very high level thing. So we'll be requesting you to check it at your side with some web or any other thing. But if there is any doubt, quickly ask me in the next session. We can quickly discuss the same topic again. Okay. So in a particular, I mean, the WhatsApp group, I'll be posting a quick link for installing MySQL database. On top of that, we will be performing SQL languages from the next day onwards. So please install the same thing at your system. It's very less, I mean, in size as well. I mean, it is not big size, it's less size. I mean, it will not take much time to install as well. Please install, and then we can quickly check what we can do in next session. Okay. So I think we have covered most of the thing. There is nothing for today, as this is an introductory class. So more things or more insights should be there in tomorrow's session with the databases and SQL query languages. Those are very interactive as well. So let's keep in touch in tomorrow's session. So any doubt for today's session till now? Any doubt from anyone? Any more questions or any particular topic you want to highlight more from your side?
No, I think we're good.
Okay, thanks for understanding. So maybe from tomorrow's session, it should be very much interesting one. So let's connect tomorrow.
Hi, Soptek Nandi. This is Varun.
Yeah, hi Varun, tell me.
So you said about SQL, right? So what
Yeah.
about Python? Are you going to teach that Python or
Yeah,
after
yeah,
SQL?
yeah. After SQL, we'll be learning Python. Okay.
Okay.
So
Okay.
this week, we'll be starting SQL maybe tomorrow or the day after tomorrow. Okay,
Mm-hmm.
tomorrow I'll be going ahead with some normalization part, foreign key, primary key concept. Those are theoretical concept on top of tables. So you can quickly
Okay.
learn those stuffs tomorrow, and the day after tomorrow we'll be learning the SQL.
Mm-hmm.
It should be taking time, maybe the entire this week or maybe early of 1 or 2 more days in the next week. After that, we can start off Python. Python as the
Okay.
basics for 2-3 days. Then we can cover more 2-3 days for Python as data engineer tool. Okay. So this is the
Okay.
overall plan.
Okay.
Okay.
So any visualization tools covered in this session?
No visualization tool should be covered over here. So
Okay.
basically, yeah, if you need any guidance, if you have any visualization tool over there at your side, I can help you. I have just to be frank. I mean, I have the expertise on Click part, so I have worked in ClickSense as well. So at the end of the chapter, if we have some time, and if anyone, I'll be asking from Lohit if we have any license because those particular product is having licensing cost. Those are 15
Okay.
days trials as well for Tableau, ClickSense, but from my IDs and everything, it's already been covered. But if there is any licensed version over there, I'll be asking from the admin over here. If we have any, then we can try to learn these things for 1 or 2 days. Okay.
Okay. Okay. Okay. Thank you. Thank you, Soptek.
Yeah. Okay. Anything else from anyone? Otherwise, you can drop off and quickly connect for tomorrow's session. Okay. Hopefully, no. So I'll be just pinging you that particular video link. So I'll be
Sure.
requesting you to install at your system. Then that should be very much interactive. Very much interactive. It should be. I mean, very much fun. We can have the sequel and everything. Okay, then. Thanks, everyone.
Okay.
Bye-bye.
Yep. Thank
Bye-bye.
you.
Yeah.
Bye.
Thank you. Bye bye.
Thank you. Bye-bye. Have a great day.
Too.
Thank
Bye.
you.